Okay, so solving quadratic equations by finding the square roots. There's many methods of solving equations, right? Quadratic equations. This is just one method, and it is solving by square roots. Now, when you're taking square roots of a number, we want the exact value.
Stick my hand in there?
Sure, well, how else are you going to get it?
Well, I don't know.
It's clean, right?
My hand?
You didn't lick your hand or anything,
Clean-ish.
right? Oh, now you screwed it up.
That's fine.
Yes. Okay, so your perfect squares. Your perfect squares are up on top. You also have this in another place. Where is it?
On your chart.
On your chart. Good. I don't have any more. Okay, these are the perfect squares because they're just those numbers squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared, 81, 10 squared, and dot, dot, dot. Now, this is called the radical symbol. Okay? The radical symbol and what's underneath the radical symbol is called the radicand. You will probably never hear that again unless you take higher mathematics. Now, at this point, for at least a week, you cannot take the square root of a negative number for at least a week. You will in about a week. Okay? The radicand, the radical sign, doesn't have to be square roots. Okay? As you found out when we were graphing radicals, it can be cube roots, fourth roots, fifth roots. But if there's no index there, it's a square root. That's why most of the times we just call it square root. But technically it's the radical. Okay? Now, point 9. That's all I got. Okay, now, back when we were simplifying radicals, I had you guys split them up between perfect squares and imperfect squares, right? Kind of like, teachers and you guys. Okay, what's the largest perfect square that's a factor of 24? Well, let's see. We can't start at 25, so we have to start at 16. 16 is not a factor of 24. 9 is not a factor of 24. 4, however, is a factor of 24. So that's my perfect square. 4 times 6 is 24. 6 is an imperfect. Now I can simplify this. Now, this is review. Okay. Square root of 4 is 2, and then I have radical 6 left over. Okay. We did this like a couple of weeks ago. And you asked me, and Kylie, you asked me if I was on LSD.
No, I
What?
didn't ask you if you were on it. I asked if you tried it.
Kylie.
He does. I remember Kylie. Well, when did you call me Kylie? So now we
Yeah, one day I made the mistake of calling her Kylie, so now it's Kylie. Okay, square root of 12. Perfect squares, imperfect square. Let's see, 12, that means I have to start at 9. 9 is not a factor of 12. 4 is a factor of 12, and it's perfect, kind of like teachers. And 3 is imperfect, kind of like, those people up there. And the square root of 4 is 2, and then leave the imperfect is my answer. Oh yeah, this is it. Square root of 88. Let's see, 36 is not a factor, 25 is not a factor, 16 is indeed a factor of 48. So I have square root of 16, and then the square root of 3. 3 times 16 is 48. Square root of 16 for radical 3. Okay. How about number 6? Now get in your Wayback Machine and think of properties of radicals that you did in Algebra 1. This is the same as radical 4 divided by radical 9. And the square root of 4 is 2, 3. I don't need to do every single one of them. It's review. Boy, you guys are needy. Needy. Wow. Okay, number 7. I'm gonna split this up between square root of 2, square root of 3. They're both imperfect squares, right?
Yes.
But then we get this crazy rule in mathematics that you cannot have a radical in the denominator, right?
Yeah.
How do I get rid of a radical? Don't do it. Skip it. How do I get rid of a radical? That's right. Multiply it by itself. Okay? If I multiply the denominator by radical 3, I have to multiply the numerator by radical 3 because we are not changing the value of our fraction. Radical 3 times radical 3 is 3. You guys get what I'm doing? Shh. Listen. Side note here. Shh. To get rid of a radical sign, I'm squaring it, right? Because the square gets rid of the radical, right? All this means is that I'm taking radical 3 times radical 3. That's what radical 3 squared means. So when I multiply these, I just get what's inside the radical. Okay? It's a side note. And radical 2 times radical 3 is radical 6. Here's my answer. Huh? I swear to God. Okay, radical 6 over radical 11. Again, both imperfect squares. So I'm going to multiply this by radical 11 over radical 11. Gives me radical 66 on top and 11 on the bottom. And I believe radical 66 does not have a perfect square for a factor. Okay, now, so that was all review. So this is where we kind of start some new stuff. Solving quadratic equations by taking the square root. Okay, again, what you have to do is get the square root by itself, the square term by itself first. And then we take the square root of both sides. Correct. Now, here's the tricky part. Thank you. Here's the tricky part. When you're taking the square root of a solution, and you're getting a solution, an answer, we don't know if you're talking about, because 16 has two factors that are squared to get the product of 16. We don't know if we're talking about positive 4 times positive 4 or negative 4 times negative 4. Both of them give us positive 16. So what we have to do is put this plus or minus sign because we actually have two different answers. Okay? I will get there. Hang on. Okay, so number 10. Again, I have to get that x squared by itself. So I'm going to divide by, think of it, the coefficient 2. Okay? You have to divide first. So I get x squared equals 25. Then I have to take the square root of both sides. Cancels out the power 2. So x equals positive and negative 5. Get two answers. Now, yeah, you worked ahead of me with number 11. Here we're going to have, we have to get the x squared by itself. So I'm going to subtract 1, subtract 1. I get 2x squared equals 7. Now I have to divide both sides by the coefficient 2. I get x squared equals 7 halves. Now I have to square root both sides. So x equals plus or minus the square root of 7 over the square root of 2. Remember, I cannot leave radicals in the denominator. So I have to multiply this, simplify this, by multiplying it by radical 2 over radical 2. So this equals radical 14 over 2. Don't forget your plus and minus sign. Yes, when you're square rooting for a solution, it has to be plus or minus. If you don't, it's wrong. So these are getting tougher. I'm glad you guys are paying attention. Add 5 to both sides. Okay, I get x squared divided by 3 equals 12. How do I get rid of 3 in the denominator? That's right, multiply both sides by 3. I heard it. So I get x squared equals 36. Square root both sides. So x equals plus or minus 6. Okay. Now it's going to get a little harder. Part 3. This time I have to get the quantity x plus 5 squared by itself. So I'm going to multiply both sides by the denominator 3. So that my 3's cancel the 1. 1 times x plus 5 squared is x plus 5 squared equals 7 times 3 is 21. Now I have to take the square root of both sides. Square root cancels out the power 2. I get x plus 5 equals plus or minus the square root of 21. Now, x is not by itself, is it? So, I have to subtract 5 from each side. 5's cancel. I get x, and we always put the real number first. Negative 5 plus or minus the square root of 21. Easy peasy, right? No. Usually I get about 75% of the class understanding it the first time, then I get it to about 85%, then the rest of you have done the third problem. Yeah, it's just like solving an equation. It really is. Can I go on? Are you ready? Okay. This is being, the quantity x minus 1 squared is being multiplied by 5, so I'm going to undo it by divide by 5, divide by 5. 5's cancel. I get x minus 1 squared equals 10. I'm going to square root both sides to get rid of the power of 2. So I get x minus 1 equals plus or minus the square root of 10. Now I'm going to add 1 to both sides. So x is going to equal positive 1 plus or minus the square root of 10. Now, these are unlike terms, so that's why we got to keep them separate. Okay? 1 and radical 10 are not like terms. It's kind of like x and 2 plus 2. You can't add them together. Okay? Do the next one by yourselves. What do you get? What do you got? Are you done yet? You could think of it as being divided by a half or multiplied by 2. Nathan, what'd you get? What'd you get? Aren't you done yet? Dividing by 1/2 is the same as multiplying by 2. Yes. Kind of. Almost. You're almost right. If I heard you right. You're almost done. Huh? What? I swear to God. Here we go. I swear to God. I swear to God. Plus or minus 7? What are you talking about? Are you doing 15? Yeah, you divide it by 1/2 or multiply both sides by 2, right? They cancel, and then I get x plus 8 squared equals 28, right? Or divide by half. And then we square root both sides, right? Well, look, listen, guys. If I have 1/2 x equals 4, I can either divide by a half Or, because it's the same thing, when you divide a fraction by a fraction, you have to flip the fraction and multiply. Okay? This is basic elementary 4th, 5th grade multiplying and dividing fractions. Okay? So, instead of dividing by a half, do a shortcut, multiply both sides by 2. Okay? All right, now, so we square root both sides. I get the x plus 8 equals plus or minus square root of 28. Now, subtract 8 from both sides. I get negative 8 plus or minus square root of 28. However, are we done? No, because we can simplify the square root of 28. Okay? The square root of 28 is the square root of 4 times the square root of 7. So x equals negative 8 plus or minus square root of 4 is 2, square root of 7. Okay?